cuboid, right? On this we will place a cuboid of cube of 5 centimeter side, right? So we can take 2.5 centimeter from here and 2.5 centimeter from here, right? And draw parallel lines like this. This is 2.5 and this is also 2.5, right? And on these also 2.5 here and 2.5 here, and we will complete the base of the cube, right? We all know that perpendicular lines remains perpendicular, right? Perpendicular lines remains perpendicular. This is a rule of isometrics. Okay? So we can draw vertical lines or perpendicular lines straight up, right? And side of the cube is 5. So we will mark on any edge 5 centimeter. Say this is 5 centimeter here. Then we will again draw parallel lines to complete the top, right? In the end we can dark all the edges which are directly visible to us, right? Top of the cube will be directly visible to us, so we will dark this line, right? This is top of the cube, and this edge, vertical edge of the cube will also be visible. This edge will also be visible, this edge will also be visible, and this baseline of the cube will be visible, this will be visible, right? Rest all lines are in guidelines only, right? And for the base cuboid, from here dark this also, dark this also, and dark this line also, right? And vertical lines, all the edges which are directly visible to us we can dark. So this gives us an isometric projection of a cube which is resting on a cuboid as per our statements. What we have done is, we have first drawn cuboid and then we have drawn the cube in the middle of the cuboid by drawing just parallel lines. All in this also all lines are parallel to either this axis or this width axis, or all rest of the lines are perpendicular or vertical to this OC axis. I hope it is clear to you. So now let us take a third example which is not a statement type question. In this third example you are given an orthographic drawing, right? Say this is the drawing which is given to you. Say plan is something like this. Say, right? And elevation of this plan is something like this. Right? And side elevation is something like this. Right? So this is a given orthographic, ortho. Orthographic drawing of object, and you are supposed to convert this drawing into isometrics, and there will be dimensions also, like say this is 8 and this is also 8, this is say 4 and this is also 4, right? Say all dimensions are in centimeters, and height wise say this is say 2 and this is say 4, and total height is say 6 centimeters. say all dimensions are in centimeters and this is the given orthographic projection, you can convert this into isometric. So, how to convert this sketch into isometric? Again, we will start with a line, we will draw a horizontal line, right. So, there are many ways to draw orthographic projection, sorry, isometric projections from the given orthographic projections. One way is you just calculate the maximum length components, calculate maximum length, right. Maximum length in this case can be, say this is length, say its maximum size is 8 centimeter, right, and maximum width from this orthographic we can clearly see that width wise maximum width can again be 8 centimeter, right, and maximum height can be 6, which we can get from elevation, say this is 2 and this is 4, so maximum height is 6, height wise it is say 6 centimeters, right. So, our object is contained in box measuring 8 into 8 into 6 centimeters, right. So, length component is 8, width component is 8 and height component is 6. So, first of all what we can do is we can draw a cuboid measuring these dimensions, right. For drawing that, now I will draw quickly. Say right. Say I have drawn a cuboid measuring 8 into 8 height wise into 6, right. So, my drawing will not go beyond this cuboid. So, for drawing this part, first say from elevation it is clear that we have a some solid which is rectangular in elevation, right, and in plan which is like a sphere. Say we draw first part, right, or we can draw the base part of the object. So, for drawing this we just need to mark 2 centimeter height on this, right, and draw a parallel line from here like this and second parallel line from here like this, right, and we can complete this also. What we have done is we have just drawn, we have just ignored the top part first, we have just drawn this base cuboid which is 8 centimeter by 8 centimeter into 2 centimeter, right. So, our first part is complete. Then we will draw this second part of the object. So, from picture we can clearly make it that it is again a cube. This is 4 centimeter, right, this is 4 centimeter and height is also 4 centimeter. So, this is a cube which is touching the top of our cuboid. So, from here we can mark, so this point is here, we can take 4 centimeter here and 4 centimeter here and draw the top of the this cube, this top, right. And we know that vertical lines remains vertical, we will draw vertical line like this, vertical line like this, right. And we also know that parallel lines, actual parallel lines remains parallel, right. So, what we can do is we can draw a parallel line like this. So, as this is parallel, these two lines are parallel, this and this edge are parallel. So, we will draw a line like this, parallel to this line, right. This edge is parallel to this edge. So, we will draw a parallel line like this, right. So, this will give us our basic shape. In the end, we can draft. We will draft like this. Top of the cube will be visible. This surface will be visible, right? So just dark these edges. Use B grade pencil or draw it with a HB pencil with little pressure, right? Right? And then dark the rest of the edges like this. This edge will be visible. This edge will also be visible. Dark this edge also. Dark this edge also. Draw dark this vertical line also. This vertical line also. This vertical line also. Right? So this is our isometric projection, right? What we are seeing is, first say this is elevation. In elevation we are seeing this rectangle, right? Say name of this rectangle is say R1, right? Its height is 2 centimeter and length is 8. So this is R1. This is R. Say R1. And in elevation we are seeing this square which is 4 by 4, right? Say this is R2. So this surface here is R2, right? In plan we are seeing one square in this corner. This is basically top of the cube. So this is a T1. So this is our T1 surface in isometric at the top, right? And in plan second surface is this L-shaped surface, right? This L-shaped surface is visible in isometric also. This is L, see? So this is T2, then this is T2 surface, L-shaped T2 surface which is visible, right? And in side elevation we can see this is S1 rectangle, this rectangle here S1, and this is say S2 square surface which is here S2, right? So this completes our isometric drawing from the given orthographic projections. And once again clearly see this angle is 30 degree, right? And all the lines are, all these lines 1, 2, 3, 4, 5, all these 5 lines are inclined at 30 degree or parallel to these edges. This edge is main length edge, okay? Right? And these lines are 1, 2, 3, 4, 5 parallel to the width edges, and rest lines are vertical. Those vertical lines which are vertical in orthographic projections, right? Yeah, actually those lines are vertical. I hope you understand this. So practice some more similar examples from the book and we will meet in the second lecture. Thank you.